Here's problem 1620. The figure below represents a string which has a heavy section and a light section. The mass per unit length of the heavy section is 16 times as large as the mass per unit length of the light section. When the string is under tension, the speed of a pulse traveling in the heavy section is blank times the speed of that same pulse traveling in the light section. Well, in general, the speed on any part of this vine is equal to the square root of the tension over the mass per length. And we're going to presumably have the same tension all the way through, but the mass per length is going to be different. So in this first section, the speed is actually equal to the square root of the tension over the mass per length there. And in the second section, the speed is equal to the square root of the tension over the mass per length there, mu2. We're also told that mu1 is equal to 16 times mu2. Hence, velocity 1 is going to be equal to the tension over mu1, the square root, which is actually the tension over 16 times mu2, square root, which we could write as 1 over 16 square root times the tension over mu2. Square root of 1 over 16 is 1/4, so this is 1/4, and then t over mu2 square root is velocity 2. So the velocity 1 of waves in that section is 1/4 of velocity of waves or speed in the second section, or the light section. So our answer here is 1/4 times the speed of the pulse traveling in the light section.